Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and explanation based on electrochemistry. Now I will continue with other topic questions based on cells. What are the main feature of different cells I want to discuss. There are many cells. Then what are the characteristics, differences between other cells? Then I will discuss that points. First, dry cell, very common cell, dry cell. And in dry, you know that in any cell, three things are very, very important: anode, cathode, and electrolyte. Question is asked. Then in dry cell, which we are using in torch or in transistor, radio, we are using that cell, that is called dry cell. Here anode will be Zn, zinc. Zinc is considered as anode, and cathode is graphite. Anode is zinc, cathode is graphite. And what are the electrolytes? Then here manganese dioxide and carbon. This is the electrolyte manganese dioxide, MnO2 plus C means carbon, and this will be near the cathode. MnO2 and carbon, that will be touching the cathode, means graphite. And other electrolytes, here only ammonium chloride and zinc chloride, that will be near the anode. It will be touching the anode, that is the zinc. Means here four total, you can tell electrolytes. First is the MnO2 plus carbon, manganese dioxide. It will be near the cathode, means graphite. And ammonium chloride and zinc chloride, mixture of both, will be near the zinc. It will be touching the anode. Now next cell is mercury cell. Then here again zinc is used as anode, and here again graphite is used as cathode, same as dry cell. But here electrolytes are different. Electrolytes is HgO, mercuric oxide plus KOH, moist KOH, moist. Then mixture of two, HgO plus KOH. Both are used as electrolyte. Third cell is lead storage battery. In vehicles only this cell is used, battery, lead storage battery. When many cells are joined to each other, then that is called battery. Okay. Then many cells, more than two cells are joined to each other, then that is called battery. Then here lead storage battery. Then here anode, as a anode lead is used. Lead is used as anode. And cathode is used. Cathode, as a cathode, lead dioxide is used. Remember it. In a lead storage battery, lead is used as anode and lead dioxide is used as cathode. And what is electrolyte? Then 38% H2SO4 acid, H2SO4 acid, 38%. Actually, you should remember difference between cell and battery, that when more than two cells are joined to each other by, actually it will be arranged in series, correct? Then that is actually called, battery, you remember. Then in lead storage battery, lead is used as anode and lead dioxide, it is used as cathode, and H2SO4 38% is used as electrolyte. Next cell is nickel cadmium cell. Nickel cadmium cell, NiCd cell. Here as a anode what you are using? Then cadmium. Cd is used as anode and nickel is used, nickel dioxide is used as a cathode. And what is electrolyte? Then potassium hydroxide, KOH solution is used as a electrolyte. Okay, in a nickel cadmium cell, NiCd, cadmium is used as anode and nickel is used as cathode, and KOH is used as electrolyte. Next cell example I am telling you, fuel cell. H2O2 is the best example. Hydrogen gas and oxygen gas fuel cell. It is called H2O2 fuel cell. Here anode what will use? Then as a anode, porous carbon containing catalyst. Porous carbon containing catalyst, and hydrogen is passed. Here at anode, carbon will be used. Porous carbon is used as anode. Porous carbon containing catalyst, and hydrogen is passed. Then including all, it is called anode. Means porous carbon containing catalyst, and when hydrogen you are passing H2 gas, then it is working as anode. And cathode, again porous carbon containing catalyst, here oxygen will be passed. Then porous carbon containing catalyst, and when oxygen is passed, it functions as a cathode, correct? Then here actually that electrolytes are not here. Here only what you are using? Hydrogen gas and oxygen gas. Okay. In a dry cell, MnO2 function as a depolarizer. Question is asked. In dry cell, MnO2 means manganese dioxide, its color is black. In dry cell, manganese dioxide is used as a depolarizer. Mercury cell gives a constant voltage. How much voltage it will give? Mercury cell. Then mercury cell gives a constant voltage, no fluctuation, and its voltage will be 1.35 volt. Through here in mercury in mercury cell gives a constant voltage, no variation, fixed. 1.35 volt throughout its life and is used in hearing aids and watches. This mercury cell is used in very important things in hearing aid, in ear. If anybody is not listening, then their aids, they will put some aid that is called hearing aids. Then in that instrument mercury cell is used, and also it is used in watches. Now reactions occurring in the lead storage battery, I am telling you. This is also very important, and many times question has been asked. Then a storage battery, lead storage battery, what reactions take place? The important is little difficult, and that's why I am telling you. Reactions occurring in lead storage battery. During discharge, actually there will be two types. During discharge, when you are using the battery, that time what type of reaction, and when you will charge, then what type of reaction, because it is chargeable, rechargeable. Then during discharge means when you are using the battery, lead storage battery, then at anode what reaction will take place, at cathode what reaction will take place, I am telling you. At anode, lead plus sulfate ion will come from H2SO4, electrolyte, correct? Then lead plus sulfate ion, it will react at anode, this reaction will take place, lead plus sulfate, and you know that at anode oxidation takes place, since it will form, lead will lose 2 electron, then lead will become lead plus plus, then lead plus 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 sulfate ion, 2 negative, SO4 2 negative, it will form lead sulfate plus 2 electron. Then at anode reaction will be Pb plus SO4 2 minus, and it will give lead sulfate. Here lead is Pb plus plus, sulfate is SO4 2 minus, plus 2 electron. Now this 2 electron will be used at cathode. Then at cathode, what are there at cathode? Then lead oxide, PbO2 plus sulfate ion will be used here also, sulfate ion from H2SO4. But main is the electron, 2 electron, that was during the oxidation, anode, that is the lead, released 2 electron, given 2 electron. That 2 electron is taken by lead oxide in the presence of H2SO4, that is a sulfate. Then it will form PbSO4 plus 2H2O, because in H2SO4 2H plus was there. Then Pb means again it will give Pb2 plus, and this sulfate, it will react, it will form lead sulfate. And now oxygen is there, PbO2, then PbO2, then Pb will be in the plus 2 plus, and SO4 2 minus, it will form PbSO4 plus 2H2O, because 2H, that is from where it will come from, H2SO4 hydrogen will come, because 2 oxygen is there, PbO2, then obviously this 2 oxygen has to use, then that's why 2H2O, then in 2H2O 2 oxygen 4 hydrogen is required. Then this is actually at anode, this reaction PbO2 plus SO4 plus 2 electron, it forms lead SO4 plus 2H2O. Now both are called half cell reaction. At anode, half cell oxidation reaction. At cathode, half cell reduction reaction. Then at oxidation you have seen there was loss of electron, but at cathode there was gain of electron. Okay, at anode electron was lost, but at cathode now gain. Then now just to add both half cell, then you will get a net cell. Then left side, actually here you will see that what will be cancelled out, you cancel it and then you add it. Then left side what will remain? Pb plus PbO2, Pb plus PbO2 plus 2H2SO4, because at anode also sulfate ion was used, at cathode also sulfate ion was used. Correct? Then that sulfate was in the form of H2SO4. Then H2SO4, then 2 times H2SO4 will be there. Then SO4 plus SO4, 2SO4 means 2H2SO4. Hydrogen will be there with them. Then lead plus lead oxide plus 2H2SO4. 2 times near the anode also H2SO4 used, and near the cathode also H2SO4 used. Hence 2H2SO4 is left side. Right side PbSO4 formed in both cases, at anode also, at cathode also. Hence it will total will be 2 PbSO4, and 2 electron will be cancelled out, and right side plus 2H2O was there, that you add. Then finally you will get net cell reaction, Pb plus PbO2 plus 2H2SO4, you will get 2 PbSO4 plus 2H2O. As H2SO4 is consumed, the voltage of the battery drops. You might have observed that when in the, you can say, vehicles, either four-wheeler, two-wheeler, in truck also they are using. Then sometimes voltage will drop, fluctuation will be there, because H2SO4 is going to be consumed. Then as H2SO4 is consumed, the voltage of the battery drops. Sometimes you have seen in motorcycle also, when you will start motorcycle and this thing light if will on, then there will be drop of voltage due to this, because H2SO4 is going to be consumed. Then this I have told you reaction during discharge time, and when you will recharge then that time what will be reaction? Then reactions occurring during charging are the reverse of the above reaction. What I discussed, just to reverse it. Reverse it means left, what is happening at the left side, that will be right side. What is happening right side, that you write left side. Means reverse of what I discussed. Okay. Finally equation what you have written, Pb plus PbO2 plus 2H2SO4, product side 2 PbSO4 plus 2H2O. Then now right side that will, you can write as a left, and left you can write as a right. Reaction will reverse. Means 2 PbSO4 plus 2H2O. After the reaction, actually generally if a battery is not working, if you will put some water or you can say acid, then again it will rework, because H2SO4 is going to be finished. Then reaction will be reversed. Just to remember, that is important things. Means 2 PbSO4 plus 2H2O, it will give Pb plus PbO2 plus 2H2SO4. This is the final reaction. I told you it will be reversed. From the right side reaction will start. It will go to the left side. Correct? Means as a reactant, left side will function as a reactant, simple way. What was the product? Now it will become reactant. And what was that time you can say reactant, that will come product. It will reverse. You remember, question is asked. Now another important things I am going to discuss. Actually, these things are, you can tell, this is the additional information. Additional information. Okay, that is asked in IIT and medical in all examination. Question is asked. That is the use of calomel electrode as a reference electrode. There are two types of electrodes: reference standard and reference. Standard hydrogen electrode, correct? Standard hydrogen electrode, that is called as a primary standard. Calomel is considered as a secondary reference electrode. Primary reference electrode is hydrogen gas electrode. Standard hydrogen gas electrode, sometimes it's called normal hydrogen gas electrode also. Then here, use of calomel electrode as the reference electrode. The use of normal hydrogen electrode, sometimes it is called a standard hydrogen electrode, is not convenient. A standard hydrogen electrode or normal hydrogen electrode, NHE or SHE, anyway you can tell. Now it is called SHE, standard hydrogen electrode. The use of standard hydrogen electrode is not convenient due to the some reason I am telling you. What are the main reason? 3 main reasons are there. Question is asked. Then first, that gases are difficult to handle because you have to pass the, in a standard hydrogen gas electrode, standard there had hydrogen gas you have to pass. Then it is difficult to maintain 1 atmospheric pressure. Hydrogen gas always you have to pass. That is the first difficulty. Gases are difficult to handle. And second, what is the problem? Then it is difficult to maintain the hydrogen ion concentration as 1 m. That is a condition of a standard hydrogen gas electrode, that always hydrogen ion concentration should be 1 m, and the pressure of the gas should be 1 atmospheric pressure. This is the actually difficult to maintain both. Always you have to maintain 1 atmospheric pressure, and concentration of H ion should be 1, H plus ion should be 1 m. Then this is the second difficulty. Third difficulty, the electrode is poisoned even by the traces of impurities. Okay, there electrodes are used. If in that electrode, platinum electrode, if any impurities is present, then that will be poisoned, means it will not work. Then these are the 3 difficulties in a standard hydrogen electrode, SHE, standard hydrogen gas electrode, also called normal hydrogen electrode. That's why it is not used. It is used only one time. With reference to this standard hydrogen electrode, calomel electrode will be unknown. Then with the use of this standard hydrogen electrode, you can know the potential voltage of calomel electrode. Then now calomel electrode you can use for further. Just to know the you can say voltage of calomel electrode, that standard hydrogen electrode is used. After knowing the value of calomel electrode, then further always that will be used. Calomel electrode will be used as secondary reference electrode. Sometimes silver chloride electrode is also used as secondary reference electrode. Then here what is actually calomel electrode? Then now I am giving idea of a calomel electrode. It is common to use a calomel electrode as the reference electrode. Its construction now you can see in the diagram. Its construction is shown in the diagram. Here its reduction potential depends upon the concentration of KCl solution. Here one thing I want to tell you. In case of a standard hydrogen electrode, there how will you know? You can say EMF or electrode potential. There you know that E standard is equal to ER minus EL. ER means electrode potential, that is equal to this ER standard electrode potential of right hand electrode minus EL. ER minus EL, that is equal to E means electrode potential. Electrode potential is equal to ER minus EL. R means right hand electrode, and L means left hand electrode. Means you require one cell. Then for a cell 2 electrode is required. You remember. Then here standard hydrogen gas electrodes, its reduction potential has been considered as a zero. Correct? Simply arbitrary, that is called arbitrarily, its value is given 0 without any reason and rhyme. 0, its value has been given. Then now hydrogen this electrode potential of standard hydrogen electrode potential, its value is 0. Then E cell value you can directly by use of potential potential by the potentiometer, directly you can say measure the E cell. If that hydrogen electrode and other electrode, as for example calomel, if you will do these 2 electrode you are using, then it became the cell. Then now for this cell, its E cell you can determine directly by potentiometer. Then now potentiometer value you are knowing, means E cell value you are knowing. E cell is equal to ER minus EL. Then E cell value you are knowing, and you can say hydrogen gas electrode potential you are knowing. Then easily you can know the unknown. You can know that is a calomel. You can know very easily. Then once you will come to know the calomel electrode potential, then now with the help of this calomel electrode potential, you can know the electrode potential of other electrode. Again, you unknown you can take one electrode, and calomel you can take one electrode. Then its value is known. Then now again with the help of potentiometer, you can know the E cell value. Then now E cell value are knowing, and calomel electrode potential value are knowing. Then unknown electrode potential you can easily know. Then this I told you how will you calculate. Then now what is actually calomel electrode I want to discuss, because question is asked. Then here I am telling you that it is common to use calomel electrode as the reference electrode. Okay, its construction just you can see in the diagram. Okay, its reduction potential depends upon the concentration of KCl solution. KCl solution is used here. Then here concentration of KCl solution, actually it will reduction potential will vary according to the KCl concentration. If KCl concentration is 0.1 N, if KCl concentration is 0.1 N, then it will give reduction potential of 0.3338 volt. You remember, if KCl solution, if its concentration is 0.1 N, N by 10, then it will show reduction potential plus 0.338 volt, plus 0.3338 volt. If you will consider N, if you will take N normal KCl, N, then now you will get 0.2800 volt less. Less means if N by 10, then reduction potential was more. Now it became N. Then now it will give reduction potential little less, 0.2800 volt. Question is asked. And when you will take KCl, saturated KCl, then now further it will be less. It will give reduction potential further less, it means 0.2415 volt. Correct? Then here you will use Hg2Cl2 paste, that is actually called calomel. Calomel, mercurous chloride is used as here, not mercuric, mercurous chloride is used as a calomel paste. Okay, and KCl solution you will take. Then here you remember KCl, that chloride ion is there. In mercurous chloride also chloride ion is there. That is the common, you remember. Okay, then this I have told you here, this is actually this calomel electrode, that now you can use their copper actually wire will be there for the connection with other electrodes through ammeter or through voltmeter. You have to connect with other electrode, calomel electrode plus other unknown electrode. Correct? If you want to know other unknown, then just to connection point to connect copper wire will be used, just to see in the diagram. Okay, and in the middle volt will be there. Voltmeter or ammeter, anything will be there, and both electrodes will be joined by salt bridge. Both electrodes will be joined by salt bridge. Correct? Already I have discussed. Now one more thing I want to tell you about the concentration cell. Concentration cell is very, very important. What is actually concentration cell? Here you know that there will be, in any cell, 2 electrodes are required, anode and cathode, and both will be different metal. But here what will happen, that actually generally just you remember that Zn was dipping in ZnSO4 and copper was dipping in copper sulfate. 2 types of electrolytes and 2 types of this were there, electrodes were there. Anode was zinc, cathode was copper, and electrolyte was Zn in ZnSO4, copper in copper sulfate. But here in concentration cell, what is special about the concentration cell, that now both electrodes will be the same. Both electrodes will be the same. Means anode and cathode will be the same. Maybe both may be zinc, both may be magnesium. Then now question arises. If both electrodes are same, then how it will function? How it will give the, you can say, E cell? Electrode potential, how will it create this cell in that both electrodes are made up of same material, zinc. Anode is also zinc, cathode is also zinc. And even the electrolyte will be the same, ZnSO4. Then now we will think how reaction will take place. How will reaction take place? Zn in ZnSO4. Again, other is also Zn in ZnSO4, and both are joined through salt bridge, and also through the voltmeter, you can say it is connected. Then now question arises, how it will react? There will be no reaction, Zn and Zn support. Correct? Anode side also no reaction. Reaction and cathode side also no reaction. Then how it will produce volt? Then just now consider the name concentration cell. Means here voltage will be produced due to the transfer of electrolyte. Both have same. Actually, there will be difference only in concentration of electrolyte. Both cases, zinc has, suppose ZnSO4 is there. Zn in ZnSO4, again Zn in ZnSO4. Then here ZnSO4 concentration will be different. Near the anode, suppose its concentration was C1, and near the cathode, its concentration is C2. Then they are differing only in concentration, and due to that it will produce volt. It will create volt due to the difference in concentration. That's why its name has been given concentration cell. It will function as a concentration cell. Here there will be no, you can say, reaction. Only there will be transfer of you can say electrolyte from anode side to the cathode side, or from cathode side to the anode side. Then here how will you represent the concentration cell? Then it is very easy. Both side you write same electrode. Means H2 oblique H plus. H2 oblique H plus. That is the one electrode. Other electrode means H2 gas oblique H. H plus means it is showing oxidation. H plus is in the last. H2 oblique H plus. H2 is converting into H. I am giving example of hydrogen electrode. Both are hydrogen electrode. Then hydrogen is converting into H plus, oxidation. Correct? And other side H plus will convert to H2 gas. And both will be separated by salt bridge. Then see, both are hydrogen gas electrode. Only difference is that one electrode is functioning as a anode, other is functioning as a cathode. Then concentration is only different. Anode side you can write C1 in bracket, and cathode side you can write C2. Near the, wherever you are writing H plus, there you write concentration, means concentration of H ion, because electrolyte concentration will differ for that purpose. Then suppose anode is C1, then cathode side H plus is converting to H2, and there also, there you consider concentration as C2. Correct? One concentration is C1 at anode and other is C2. Correct? Another example you can take as a zinc. Then actually you can write cell as usual. Zn is converting to Zn plus plus, oxidation. Correct? And Zn ion will convert to Zn as a cathode. Actually in the galvanics, in this concentration cell, it is also galvanic cell. But here no net cell reaction. Reaction will take place such a way that finally there will be no net cell reaction. Just only formalities will take place. That oxidation will take place at anode and reduction will take place at cathode. But finally no net reaction, only transfer of material from anode side to cathode side. And here also for zinc, suppose you want to write, then Zn is converting to Zn plus. The Zn oblique Zn plus plus its concentration you consider as a C1. You write in the bracket C1. And other side Zn plus is converting to Zn metal. Then their Zn concentration is C2. And both are separated by salt bridge, double line you can write. Then at 298, then what will be the, you can say, EMF of this cell, concentration cell at 298 Kelvin? Then you remember here E is equal to same way Nernst equation. Okay, but here as E is equal to E naught, you have to not write. A standard electrode potential is not required. Okay, here directly you can write E is equal to 0.0591 divided by N log C2 upon C1. Here C2 is greater than C1. C2 is greater than C1. Correct? Then you remember in concentration cell E is equal to 0.0591 divided by N log C2 upon C1. Actually here this is a final derivation I told you, but here when ER minus EL expression you will write for both electrode, anode and cathode, because at anode also reaction takes place, at cathode also. Then Nernst equation for electrode potential, Nernst equation for electrode potential separately if you write, you know that their expression is same as for E cell. E cell expression and for electrode potential Nernst equation is same. Correct? Hence if you will write, if you will for the anode and cathode, if you will write the expression in the, and that is the ER minus EL, then after writing the expression for EL Nernst equation, again for other electrode left ER minus EL, then for the ER you will write Nernst equation minus again for EL Nernst equation. Then here you will see, because a standard electrode potential will be common, then both will be cancelled out because in the middle minus is there. Then after the arranging only, because for one electrode concentration is C1, correct? For right side it is a C2, but for left side C1. Then after simplifying you will get this equation. Okay, that is the C2 upon log C2 upon C1. 0.0591 upon N you can take as a common. Then you will get actually log C2 minus log C1. You will get then log C2 minus log C1 you can write as a log C2 upon C1. And 0.0591 divided by N will be common. And E standard plus E standard minus E standard, both will be cancelled. Then this I have discussed about the concentration cell. Now I am stopping only here, and one more class I will take, then this electrochemistry it will finish. Okay, thank you.